The H-parameter model is an alternative to the hybrid pi one which we're already familiar with. It's based on circuit matrices as discussed in the last video, but tends to be used with the individual parameters in a similar way to the hybrid pi one, rather than as a matrix. The term H comes from hybrid because it mixes both voltage and current parameters together. The formula is shown on the screen. The matrix is widely used because several of these parameters turn out to be very useful in transistor calculations. We can see this if we put a common emitter transistor into the circuit block and relabel the parameters slightly. H11 or HIE is just the input resistance, which is equal to RBE in hybrid pi model. H21 or HFE is the current gain, which is the same as beta. And H22 or HOE is just the output admittance, which is 1 over the output resistance, which is 1 over RCE in the hybrid model. In the labeling, I stands for input, F stands for forward, meaning something which feeds from the input to the output. R stands for reverse, meaning something which feeds from the output back to the input. O stands for output, and E stands for common emitter. We can write the model down as shown on the screen. We already know that HIE, which is the same as RBE, and HFE, which is the same as beta, are important. The other two parameters are useful in more specialized circumstances, a little bit like the additions to the hybrid pi model which we've already discussed in a previous video. It is also possible and useful to write down H-parameter models for common base and common collector connected transistors. In the common base example, the parameters are HIB, HRB, HFB, and HOB. And the setup is as shown on the screen. In the common collector, they are HIC, HRC, HFC, and HOC. These common base and common collector parameters can be calculated from the common emitter ones using a standard set of formulae, and these formulae can be found in many basic textbooks about electronics.